Okay, so we're going to get back to section 1.3 and find the domain. We'll do some other things also. The first one, f of x equal x plus 1 over 5x minus 3. We know we can't divide by 0. So if I take the function and what's in the denominator and set that to be equal to 0, and then solve, x cannot be 3/5. So my answer is the set of all x such that x is not equal to 3/5. Same thing in problem 2. So g of x is equal to 3x divided by x minus 4. I can't have x minus 4 being equal to 0. So just on the side here, x minus 4 is going to factor nicely as x plus 2 times x minus 2. And that means that x is equal to negative 2 and x is equal to positive 2. That's what we don't want. So the set of all x such that x is equal to negative 2 and x is equal to positive 2, not equal to, it would be the answer. Problem 3, h of x is equal to 3x divided by x plus 4. So I'm interested in the denominator. I know I can't divide by 0. So if I set the denominator equal to 0 and then solve, I would have all real numbers would be okay. So x squared plus 4 equals 0 means that x squared is equal to negative 4. X can be anything, so x squared can be anything. Now if I square a number, I'll never have a negative. So there's no number that would be equal to negative 4 when I square a negative and then when I square a negative. X squared equals negative 4 has domain all real numbers. The next one, k of x equal 3x divided by x squared plus 2x minus 3. So I want x squared plus 2x minus 3 to not be equal to 0. If I set that to be equal to 0 and solve, x squared is equal to negative 3 and x squared is equal to 1. That would factor nicely as x plus 3 times x minus 1. X plus 3 times x minus 1. And that's what I don't want. So I don't want x to be negative 3 and I don't want x to be 1 would be the solutions. In the case of f of x equal the square root of 4 minus 3x, so the number underneath the square root sign can never be a negative. The square root of a negative is not a real number. So I would set 4 minus 3x to be non-negative, greater than or equal to 0, and x is less than or equal to 4/3. So anything less than or equal to 4/3 would be okay to use in the domain of f. The cubed root of 4 minus 3x. So the cubed root of a number is different from the square root of a number. The cubed root of 8 is equal to 2. The cubed root of negative 8 is equal to negative 2. So negative 2 times negative 2 times negative 2, or negative 2 cubed, gives me negative 2 cubed, what would be the cubed root of negative 8, if I simplify. And that's okay. The cubed root of any number is just another number. The cubed root of 4 minus 3x would be all real numbers. The h of x is equal to the square root of x squared plus 1. So the domain of h, I'd want to set that to be such that x squared plus 1 is greater than or equal to 0. X squared is greater than or equal to negative 1. And when I square any number, I'll never have a negative. So every time when I square a negative or any number, I'll have a result that is greater than or equal to 0. The only time I'll get 0 is when I square 0. So 0 squared gives me 0. 0 is still bigger than -1. And so all real numbers would be okay for that one. K of x equals the square root of x divided by x minus 4. So a couple things. First of all, I see the square root in going on, and then I'm also dividing by x minus 4. Okay, so the square root of a number is never going to be a negative, which means that x can never be a negative. Now, in the denominator, I can't have 0. So while x can never be a negative, I don't want x to be 4, because 4 minus 4 gives me 0 in the denominator. And so I could set that equal to 0 on the side somewhere if I wanted to, or just see that x minus 4 equals 0 is what I don't want. So the set of all x, if the x is greater than or equal to 0, or not equal to -4, or not equal to 4, is the domain of K. The domain of f of x equals the absolute value of 2x minus 1. So if I throw on absolute value bars in the expression, the domain is all real numbers. Really, when it comes to domain, at the moment there's only two things that I'm looking for. Number one is that I can't divide by 0. Number two is that I can't divide by, or I can't have a negative underneath the square root sign. Okay, so I don't have any division or anything with an square root sign, and so all real numbers would be okay for f of x. Okay, the next thing here is a graphing example. I want to graph the plotted points and then state the domain and the range. Okay, f of x equals -x squared plus 4x minus 3. So I'm just using a table of values and then plotting the corresponding points on the xy plane. When x is -1, I get -1 squared is -1. Minus 4 is -5. Minus 3 is -8. So -1, -8, that's down here somewhere. When x is 0, I get -3. So here's 0, -3. When x is 1, I get -1 plus 3 minus 3 is -1. Excuse me, when x is 1, I get -1 plus 3 plus 4 is plus 3. Minus 3 is 0. So 1, 0 would be on the graph. When x is 2, I get 2 squared, which is a negative, 2 squared, plus 4, or plus 8, minus 3 is 1. And when x is 3, I get -9 plus 12, and then minus 3 is 0. So here's 3, 0. And then when I plug in 4, I get -16 plus 16 minus 3 is -3. So the domain, it looks like I can plug in anything. I've got no division going on here. I've got no square roots or any other radicals that I got to worry about. So all real numbers. In other words, the graph of f of x is going to cover both the x-axis, and so the indication here that the graph has downward and outward in both directions means that it's going to cover both the x-axis and the y-axis, the range is the set of all y's such that y is less than or equal to 1. Well, so here is 1. So if I take a look at the y-axis, here's 1, and anything that's 1 or less on the y-axis, when I look to the left or to the right, I'm not on the graph at all. So and anywhere that is 1 or bigger, I'm not on the graph. Anywhere that is 1 or less means that I am on the graph. So make sure that using the variable y for the range, x has already been defined, and so we want to make sure that we're using y for the range of a function. Okay, we'll go ahead and stop right here.